Hello and welcome to your midterm project. For this assignment, we're going to take something straight out of the book on page 118 in chapter 3. At the end of chapter 3, we're going to do exercise 9 and draw a structured flowchart or write structured pseudocode describing how to tidy up an apartment. Include at least 2 decisions and 2 loops. Now, if you're absolutely positive you know how to do that and want no further reminders of anything, you can close this video, but I don't recommend it. We're going to just real briefly here review structure and how to make sure something is structured and even show an example of what this is going to look like. In fact, we're going to show you the solution to number 10, which is almost identical. In fact, it really is. It just is going to be different than what I want you to produce. So, just going back over, I know it's been a little bit since we've been on chapter 3, and hopefully in the other assignments this has kind of been reinforced, but let's just go real quick over the 3 basic structures. The whole point is so we don't have spaghetti code that looks like this, jumps all over the place. We can solve the same problems with much better and easier to read code, and avoid logic errors a lot easier if we actually use structure. So we have 3 basic structures, as we know. We have the sequence structure, the selection decision structure, as we tend to call them if statements, and a loop structure, which we typically refer to in terms of the while loop, although there are other types of loops. But basically anything can be done with a while loop. So we'll go ahead and there we go. Alright, the first one is the sequence structure, which is very simply just a series of tasks. Since I'm a runner, I'm going to use these examples of if I want to go run 3 miles, I run 1 mile, and then I run another mile, and then I run my second mile, and I run my third mile. It's just a series of steps that I take. Literally, series of steps. And that's simply a sequence structure. We do that kind of thing every day with just ordinary tasks, and we don't really think about it, but this is just the way a computer looks at it. A selection structure is going to be if, then, else, something else. This is what is called a dual alternative if, and so I might say, well, if it's daylight outside, I will go for a run. If it's not, I will stay inside and play video games. I don't know. Whatever the solution might be there, that's a dual alternative if. And in pseudocode it looks like this. If the condition is true, say if it's daylight, then do something else, do something else. We also have single alternative ifs where we just determine, if it's daylight, I would maybe go for a run. There is no else. I don't do anything if it's not daylight. So it looks like this, and it just means you don't have any steps to take if that condition is not met. So, like, I think we had an example of a billing program where if they met a certain condition, then additional fee was added to their bill. But if they didn't, then no fee was added, so nothing happened. It just continued on with its programming, with its processing. So that's that. Then we have the loop structure, which also asks a question and has a decision that has to be made. We call it repetition or iteration as well. And it looks simply like this. Now, don't get fooled by this idea that there's just this one step over here or whatever. You can have any sort of complex things in here. We'll cover that in a moment. But it simply asks if a condition is met. If it's true, everything on a computer has to come out. When you ask a question, it has to be a binary result. It has to be yes, no, true, false. Because everything on a computer is zeros and ones. So that's the only way it knows how to understand. You have to break it down to that level. And with a loop, as we've talked about already, it has to come out true for the loop to execute. Otherwise, it just goes on and doesn't not continue the loop. So that's what that looks like. We have the while, do something, and so on. So all logic programs, no matter how complex it is, can be solved using just these 3 basic structures. You can stack them, you can nest them, and we'll go over, if I could get my cursor where I wanted it. Here's just a simple example of a stack. We have a sequence, a two-step sequence, and then we have a dual alternative selection structure with a couple of steps depending on, or single step depending on which yes or no, and then we have a loop that has another step depending on if that condition is met. And that's just simply stacking. What's important here is that each structure is the entry and the exit. It has one entry and one exit basically, and you can also nest them, because simply stacking is not going to let you do anything very complex, but nesting gets you the ability to do a lot more. This is actually just really simply the single alternative if structure that we looked at a moment ago, but it's been expanded on with more steps in what we would call a sequence. So you can think of it as we've inserted a sequence entirely into this selection structure. And the key is that the entire structure gets inserted so that there's no spaghetti, there's no other paths of exit. There's still just this one entry, one exit, one entry, one exit to each of those structures. And we can continue to expound on that by adding a loop in here. And so remember, the loop has the one entry point right up here and one exit point down here, and that's been inserted into part of the sequence, which is in turn part of this selection structure. And you can continue to compound that and add another selection structure inside of that loop, so that if the loop is supposed to execute, we have to determine whether one of these other conditions, or this other condition, is true, and execute one of these other steps based on that. Still, one entry point to the selection, one exit point from that selection, and that continues to be met. So that's the basics on that. The problem then with a loop is we often need a priming read, and this is where you can often get an unstructured bit of code, is if they do not follow the proper order. So let's take a look at what that would look like. Here is a structured but non-functional flowchart of a number doubling program, as it says there. We would come in, we would receive the number, we would prime the loop, and then we would ask the question, and since it's not end of file, they put in a valid number, we would go ahead and do this output calculated answer. But when we come back here, we didn't ever get a new number. We're still got the same number, so we've created an endless loop. So a simple way we would think, oh, we can solve that by just coming in up here above that, and boom, we're good. Well, no, because now it's not structured. We have broken that single entry, single exit point, because now it can also exit up here, and because this is not actually part of the loop. So the proper way to do that is to do this. We actually receive the new input at the end of the steps that are done inside the loop, and we just have to have this additional code that we call the priming input, or the priming read. We've actually seen that in quite a few of the debugging assignments thus far, so hopefully that's familiar to you. And this would be another incorrect solution, would be to move this inside of here, because we would get that number the same way, but then we would not have the number in time to determine whether it's end of file. So that would also be a problem, because well, we'd actually get the number after we've asked that, and if they put in the end of file value, we may not be able to double it, and we've actually crashed the program potentially too. So a lot of ways not to do it, and some reasons for why we have structure. So sorry this part took so long. I did not mean to make this video so long, but we'll just get through this other part really quick. So what is the assignment? The assignment is to create pseudocode or flowchart. You do not have to do both. You can do either one, whichever is easier to you. In a lot of ways, pseudocode is going to be easier to me, but to a lot of you, flowcharts are easier. They're potentially harder to create, which is why I'm giving you the choice, but it's up to you. You can use Word, you can use PowerPoint, you can use a great little program called Visio that most of you probably don't have a way to get, so that's fine. But if you do, that would be fantastic, a way to submit your assignment. If you want to write it out, draw out a flowchart on a piece of paper, scan that in, and email that to me, or not email it, but submit it in the Dropbox. That's also fine. So the basic idea is just to do this. This is the example of exercise 10. So we have our pseudocode start to stop. We have the requirements being met of 2 whiles and two loops and 2 selection structures. And then you can see them over here in the flowchart. We have our start and we have our loop here. We have a selection structure. We have another loop here. Don't get fooled by the fact that there is more steps here. It's still just a loop. We have another selection structure and so on. So we get to the stop. So real briefly, if you want to do this in PowerPoint, here's something I threw together. I created these little boxes on here and the arrows, and there's a sequence structure. There's our decision structure, selection structure. We ask a true or false question. We get some action or inaction. Same type of thing here. We have a loop control question. Has to be true or false. We take some action or we proceed. And here's kind of an example of putting it all together in a way I've nested a sequence into the yes branch of the selection structure. I nested a loop into the no branch of the selection structure. You can, do whatever works for the logic that you create, and it really is up to you as long as it meets the simple requirement of having 2 ifs, 2 selections, and 2 loops. If you do it in PowerPoint, you're probably going to need more than 1 slide, and as long as I can follow how it goes, that's fine. To create the start and stop, we'll go over here to the insert and do shapes, and we have all these. Actually, here's your flowchart. Here's your rectangle, like for a step to take, and here's your diamond, the decision structure, and then here's, like I said, the start and the stop. So if we click that, any of those, you can then draw it out here and put that in. And then you can also use, we have various lines, things that you can use to connect the multiple shapes. And in fact, if you double click on one of them, I think you get some options up here that are quick, easy ways to do that. So hopefully that gives you a good little start. If you have any questions, feel free to drop me an email this week, and I will get back to you as quickly as I can. Hopefully this just helps to reinforce and extend your understanding of structured logic. And just going back here as a reminder again, that is on page 118 in chapter 3, exercise 9 is what I would like you to complete. Thank you.